My name's Nevin Lawrence. I'm a graduate student under Ian Burke, and together we make up the weeds component of Objective 5, the biotic group. And I'll be talking today about protected changes to Downy brome herbicide application timings. So for the majority of what we've done for the weed component of Objective 5 is look at this weed species called Downy brome. And the reason we've been looking at it is it has a lot of attributes that lend itself to this project. Among them, Downy brome is one of the most widely distributed weeds in the entire western US. You can find it in natural areas, rangelands, CRP, and agronomic areas. And anywhere we look in the Pacific Northwest and small grain production regions, we can find the weed, and not only can we find it, it's also a problematic weed in all those areas. Another attribute that makes it particularly suited to this project is there already exists a published model of Downy brome development based on growing degree days. And this growing degree days, if you're not familiar with it, is a way to calculate heat units as calendar day increases, where you take a single day and you take the max temperature and you take the min temperature, add them together, divide that by 2, and that's your growing degree day for, that's your number of growing degree days for that calendar date. And so those accumulate throughout the year. And what Dan Ball did, he's the one that developed this model out of Pendleton for Oregon State University, is he took Downy brome collections from the entire western US, grew them together in a bunch of common garden experiments, collected seed as it was being produced and planted it, and if that seed was able to produce a plant, that was considered mature seed. And then he used some nonlinear regression parameters, which I'm not going to get into, to estimate when the mature seed could be produced based on these models. And these are results of that, how many growing degree days were required to produce mature seed throughout the western US. And there's not really a lot you can glean from this, but if we just narrow it down to the collections from the Pacific Northwest, what we find is it's a lot more consistent. There's a lot less variability in when these plants mature. And that was the conclusion of his study, is that around 1,000 growing degree days seem to be a very important marker for when Downy brome produces mature seed. So we took this value, 1,000 growing degree days, and we went over to Idaho and talked to John Abotsoglu, and he was able to compare historically when we were having 1,000 growing degree days being reached from 1950 to 2005, and then using 14 climate models that he found to be pretty accurate for the Pacific Northwest based on historical climate. He's able to project when we would reach 1,000 growing degree days through 2031 to 2060. And that's what we're seeing here, is what the change is in days based on calendar day. So this left image is the mean of those 14 models. The image in the middle is the second largest change, and the image on the right is the second smallest change. And some of these models are showing 25, 35 days change in when mature seeds being set. But I think even more striking is all these models are showing advancement. This plant is going to be maturing a lot sooner than it has in the past with climate projection. So what's that mean? That's really interesting from a biological standpoint, but what's that mean to growers, and what's that mean to other people who are interested in this weed? One of the characteristics of Downy brome that can distinguish it from other winter annual grass weeds is that it matures very quickly. A lot of the winter annual grasses that we have as weed problems, they tend to have a similar life cycle to, let's say, winter wheat or other winter annual grains that we grow. But Downy brome can actually develop mature seed while wheat is still in anthesis, depending on the area where it's being grown, which is pretty early. And because of this, it develops very soon. We also need to control it very soon. And currently, not projected in the future, but currently, we have a hard time controlling Downy brome when we make spring applications. And with Downy brome for control, there's not really any biological solutions. Cultural practices are very inconsistent. And a lot of the regions here use conservation tillage, so tillage isn't a tool either. So the really only option we have left are these herbicide applications. And if you read the literature, you do look at a study about comparing herbicide applications, you find that spring applications, if it's a 5-year study, you might have 1 year with very good control, and the other years are going to be very inconsistent and not good enough. And the reason for this is generally when we can get out in the field. It's not an issue of the herbicide, it's not an issue of the weed, It's just a matter of getting out to the field to make that application. The soil's either too wet or you're looking for a 5 or 10 day window to get into the field to make those applications, and you're just not being able to find that. So this is a snapshot of Whitman County, where the campus for WSU is located. And just to show you the variability we have in spring moisture. So this is total moisture between March, April, and May for the past 100 years. And that line going across there is the average that we've seen. And some of these years we have less moisture than others, and those are generally years where we can get good control of the weed because we can get in there early enough to make these applications. But as you can see, the last 4 years, we've had a very hard time getting in the field. And I know if we look at our protocols the last 4 years, just for in general, when we make these applications, they're a lot later than we would like them to be because of problems getting into the field. And that's sort of where we're at right now in this project. And there's a lot more to be done with it. And I stole this slide from Dave Huggins. I hope he doesn't mind. But this is just the AAZ showing how we're expecting, how climate's going to affect how we're growing regions. And this is the ultimate goal of this project, this herbicide application, timing component of it at least, is to kind of develop a risk assessment map of sort of what areas we're going to have these factors of temperature and moisture combined together to make it very difficult to control this weed. And this is something we're continuing moving on with, and I get to integrate my research with John a little bit more, and hopefully he's looking forward to that as well. And I'll be presenting this data in a few months, actually, at the Western Society of Weed Science, and there's not a whole lot of climate work and weed. Okay, thank you.